Welcome to our lesson channel. We are going to see about total internal reflection. Here, let's see the definition for total internal reflection. This is nothing but when the light travels from a denser medium to a rarer medium, if the angle of incidence is greater than the critical angle, then the ray return to the denser medium, then that is nothing but total internal reflection. That means as the angle of incidence increases beyond the critical angle, there is no more refracted ray. All the emergent rays are totally reflected inside the medium. So this is nothing but the total internal reflection. Let's see the critical angle. The critical angle is nothing but the angle of incidence in an optically denser medium for which the angle of refraction is 90 degree, which means the angle of refraction is at 90 degree, which is parallel to the surface of the medium. Also, we can say that is nothing but angle of incidence is equal to critical angle when the angle of refraction at 90 degree. So, let me through the schematic diagram, we can explain about the reflection and refraction, critical angle, and total internal reflection. In first part, let's see about the angle of refraction and angle of reflection. See, here a ray of light passes from an optically denser medium to rarer medium at the interface of x, y. It is partially reflected back into the same medium and refracted into the rarer medium along OC and reflection along OB. Here we can say that it is nothing but the incidence ray splits into refracted and reflected. Here the angle of refraction is lesser than angle 90 degree. So the angle of refraction is equal to angle of reflection. So this is nothing but the first diagram denoting about the reflection and refraction. So here in second diagram we can see about the critical angle. Let's see. Critical angle is nothing but the angle of incidence in the denser medium at which a refracted ray just grazes the surface of separation, which is nothing but the critical angle of the denser medium. So, if you increase the angle of incidence, the angle of refraction also will gradually increase. So, at a certain stage that the R will becomes at 90 degree. Now, the refracted ray is so much away from the normal, and it is grazes the surface of separation into two media, which means we can say simply that the angle of refraction is at 90 degree, which is parallel to the surface of the medium. So we can say which is nothing but the angle of incidence is equal to critical angle. So when the angle of refraction is 90 degree only. So this is nothing but the critical angle. And the third point we are going to see about the total internal reflection. Here, as the angle of incidence increasing beyond the critical angle, there we can't expect the refracted ray, only we are getting the totally internal reflection, which means we are getting only the reflection in the same medium. So if I is further increasing means then we can't expect the refraction. It is not possible. So the incident ray is totally reflected into the same medium itself. So this is nothing but the total internal reflection. So this is the basic things we should remember always. Say this is a Snell's law formula, right? Sin I by sin R. So we can write that is nothing but mu A. We can say that is for refractive index of R divided by refractive index of the denser medium. So is equal to sin I divided by sin R. If you say that is mu A is 1 for R, that means the refractive index of R is 1 means this substitute 1 and divided by mu D equal to sin I divided by sin R. We can know very well that R is equal to 90 degree at critical angle, right? So that's what we are putting. R is equal to 90 degree and we know very well that I is equal to C, right? So simply just put sin I is equal to sin C here is equal to 1 by mu D. Sin 90 degree is nothing but 1. So sin C is equal to 1 divided by mu D. Mu D is nothing but we know very well the refractive index of the denser medium. So here we are getting what is C. So C is equal to sine inverse of 1 by refractive index of the tensor medium, which is nothing but the 1 by mu d. So this is a basic explanation. So this is a basic derivation too. We should remember always. And also for total internal reflection to take place, that these two both points are very important, that the light must travel from a denser medium to a rarer medium only. So then the angle of incidence in the inside the denser medium must be greater than the critical angle. Then only we'll get the total internal reflection. Otherwise we can't get it. Okay, then we can easily decide I is greater than the C denoting about critical angle. These are all the applications for total internal reflection. First, for diamond. For diamond, its refractive index is 2.42 and for critical angle is 24.41 degree. So here we can say that the total internal reflection is the main cause of the brilliance of diamonds only. Then when light enters into the diamond at any phase at an angle greater than critical angle, it undergoes total internal reflection. So by cutting the diamond suitably also we will get a multiple internal reflections. So the incident rays can undergo multiple total internal reflection inside a diamond before exiting the top of the diamond. So this is for the diamond. And for optical fibers, we can say the total internal reflection is the basic principle of optical fiber actually. So an optical fiber is a very thin fiber made up of glass or quartz having the radius of 10 power minus 6 meter, which is nothing but the micrometer. So we can say here the optical fiber, see here a plastic coating here and cladding and core, and here we are giving the source of light rays. So here we can say that is nothing but that the principle of light transmission inside the optical fiber. See here the refractive index of the material of the core is higher than that of the cladding. So when the light is incident at the one end of the fiber at a small angle itself, there the light passes inside and undergoes repeated the total internal reflections along the fiber. In core we can say, so then it finally comes out. Okay, the angle of incidence is always greater than the critical angle, right, of the core material with respect to its cladding. So even if a fiber is bent or twisted, similarly see it is the bent. So even it is bent or twisted, however it is, the light can easily travel through the fiber. Okay, so the fiber optics cable is also made up of bundles of a glass fiber. See here. So the small critical angle, thus we are getting the high refractive index. So the light entering will always have an angle of incidence greater than the critical angle. Then only we'll get the total internal reflection. So the light does not escape as it travel along the fiber optics cable. So because it undergoes total internal reflection. So the light pipes are also used in medical field and optical examination also. So they are also used to transmit communication signals. This is a basic technique using in a communication signals to transmit. So these are all the basic things we should remember always. For cladding, here we are having cladding and fiber, right? For cladding, mu is equal to 1.5. For fiber, it is 1.7. So these are all the basics we should remember always. Thank you for attention. Kindly subscribe and like and share and comment in the comment box.